Hello class, this is a video tutorial on the application of trigonometric integration, example 1. Since the same concepts of the application of integration apply even to trig functions, I'm just going to go straight into the examples here. So let's find the area between y equals cosine of half x and the x-axis in the domain of 0 to 4 pi. While it's not always entirely necessary, it's best that we even just graph or sketch, the function that we are going to be integrating or finding the area of. Let's first recall the original function of cosine x. So here we have cosine x, where the period is 2 pi, but I hope we can remember that the period is going to be 2 pi on whatever the coefficient is here. Let's call it n. So in this example, it's going to be 2 pi on half. So the period is actually going to be 4 pi, which means this cycle going down and then back up, finishing at 2 pi, is now going to take twice as long. So sketching this out, it looks something like so. So this end point is at 4 pi, and all the other critical points have now been dilated horizontally. So this was originally at pi here. They're going to be doubled the distance from the y-axis. So then this is going to be at pi. This position here, which was originally at 3 pi, is going to be doubled in distance from the y-axis. So that's now going to be at 3 pi. And while it's not entirely important because it's not part of the integration, this point here is going to be at 2 pi. Now the reason why it's very critical that we graph this or we sketch it, at least even in our mind, is because we're looking for this area that I'm highlighting in purple. If we were to evaluate this following integral, 0 to 4 pi of cosine half x dx, we would get the area of 0, because the areas of 1 and 2, if you were to add them, they would be cancelled by the area of 3. This is because this area here is below the x-axis, giving us a negative area. To counter this, we have to break up the integral from 0 to pi of f of x dx. Now, because this is below the x-axis, rather than add it, we're going to minus, because we're multiplying by -1, so minus from pi to 3 pi of f of x dx, plus this area here, which is from 3 pi to 4 pi f of x dx. Now, to make this nice and easy, let's integrate just this expression without the boundaries. So this will become the integral of cosine is sine of the same function. It's going to be 1 over the coefficient of x. So 1 over half gives us 2. So for this, that's what we're going to be having for our function to integrate. This is going to be sine half x from 0 to pi. Now, rather than write 2 for all of them, I'm going to factor out the 2 out first. So it's going to be 2 outside of sine of x from 0 to pi minus sine of half x from pi to 3 pi plus sine of half x from 3 pi to 4 pi. Substituting all these functions, being very careful not to mix up all the values, so here we go. For the first one, it's going to be substituting pi, so it's going to be sine pi on 2 minus sine of 0, because half times 0 is just 0, minus substituting 3 pi, it's going to be sine 3 pi on 2 minus sine pi on 2 plus substituting 4 pi, that becomes sine 4 pi on 2 is just 2 pi minus sine 3 pi on 2. Evaluating each of these, you can do this in the calculator, or if you can remember your unit circle, sine pi on 2 is going to be 1 minus sine of 0 is 0 minus sine 3 pi on 2 is negative 1 minus sine of pi on 2 is positive 1 plus sine 2 pi is the same as sine of 0, that's 0, minus 3 pi on 2 is negative 1, so minus minus. Evaluating all of this, 1 take away 0 is 1, minus, this is negative 2 times negative 1, so that's plus 2, plus 0 minus minus 1 is 1. Putting all of this together, this becomes 3 plus 4, 3 plus 4 times 2, that's 8 units. So 8 units, actually no, should have been just u squared, makes it a lot easier. 8 units squared. And there we have it. So the area in purple here is 8 units squared. Hope to see you in the next example. Best of luck.